Today on the program, we're going to be covering lesson 1.2, variables and data types. Take a second to familiarize yourself with the learning objectives and the topics that we are going to be covering. Okay, let's get started. We're going to start off with our notional machine, and we have some code on the left. So go ahead and pause it for a minute and try to read that code and figure out what is happening. So remember, with our notional machine, we are going to read and interpret this code as if we were the computer according to our rules of precedence. So we're going to start at the top, work our way down. Each line we're going to read from left to right. So starting with line 1, we are creating a method called shopping list. Now this is the name that we just made up for this method. When Java sees that, it's going to create some space in its stack memory for this shopping list. And we're actually going to use this space in memory for our shopping list. Moving on to line 2. Line 2 starts with a slash slash. That is a comment. That is something that's ignored by the computer, but it's used to leave notes to yourself or other programmers. So we said we are going to declare and initialize variables. And so this is where all of our new code for this section comes into play. Let's look at line 3. So line 3, like our comment says, we are declaring and initializing a variable. We are declaring it as an int. An int means that it is going to be an integer number. And we are giving that variable the name quantity, and we are assigning that variable the value of 4. So when Java sees this line of code, it knows that it needs to remember this 4 in memory, and it needs to know that it's going to label that variable quantity. This is going to go in the stack memory. Now it's called stack memory because every time we create a variable, it just gets added to the stack. So it starts off, the first one goes all the way to the bottom, and then we just stack our variables on top of it. Java has a memory address for each location. So it goes to the first available memory location that it has for us, and it's going to label that with the name quantity. So it's going to label that quantity. And it's going to move in the value of 4. So quantity is going to be 4. So that's our first variable that we created, quantity, and we gave it the value of 4. Now it's called a variable because it can change values. It might not always be 4. It's just being initialized as 4, but that value may vary. It will always be called quantity, but the value may change. Moving on to our next line, we are declaring and initializing another variable. We are declaring this as type double. That means it's going to be a decimal number. We're giving it the name price, and we are initializing it with the value of 0.89. So we're going to go, when Java sees that, it goes back to its stack memory and it just drops it in on the stack. And so when we drop it in, the next available spot in memory is right there. So it's going to give it the name price, and it's going to move in the value of 0.89. Moving on to the next line, we have a boolean. So we are declaring and initializing another variable. This one is of type boolean. Boolean means that it's a true false value. We are giving it the name is delicious, and we are moving in the value of true. So we're going to go to our stack memory. We're going to name it is delicious in the next spot available. And we are moving in the value of true. Now we're going to notice that this is not a string literal. It does not have quotes around it. This is a Java word. This is a word that Java knows. It is not an English word. It means the same thing that we use it for in English, but this is Java's word for it. And you'll notice that at the beginning, this has another keyword on it that means final. What that means is that this value is locked, and this value cannot change. All the other values can vary, but if we ever declare something as final, that means that that value will be locked and it cannot be changed. That is not something that is unique to Boolean. We could have made any of these variables final. And then our final one that we are making is a string, and it has the name item, and we are initializing it with the string literal apple. So we've seen string literals before, so now we see that we are making a string variable. Now this is different than the other three types of data. These three are all primitive types of data. So those are all primitive types. This last one, string, this is a reference type. Reference. And it's going to be stored a little bit different than the rest of this because strings, words are way more complicated than numbers. It's way more complicated than a true false. So it needs to be stored somewhere else. And Java is going to store this in a special place for bigger items. These items are known as objects. So it has a separate place for where it stores objects, and that's its heap memory. And so it's going to move the value in here. It's going to move that string in here, apple, in the string pool in heap memory. And then in our stack memory, it is just going to assign the name up here, item, and the value is going to be the address from heap memory. So that one is a little bit complicated. We look at this a lot more in Unit 2. We'll look at how to store objects, how to store references to objects. Now that Java has all of this in memory, we can start moving on to the rest of the code. We're going to continue on with line 9. Line 9 has a comment. That's just a note saying we're going to output some data to the screen. We're going to use this by using some system methods that we learned in lesson 1.1. We'll be using the println and the print methods. So first we have a println, and we are passing in the argument of item. When Java sees this item, it needs to evaluate what this is. What is item? So it looks through its memory for item and it finds it right here. And it says, oh, you need to reference someplace else. Look for that in heap memory. It finds it in heap memory and it says this is apple. So item right here, that's going to evaluate to the string literal of apple. And so that's what we pass in to that println method. We're passing in the string literal apple. And so since that's a println, we're going to get apple down here in our console. And the cursor is going to move to the beginning of the next line. Next, we're using a print, and we are passing in the argument of quantity. When Java sees that, it needs to evaluate that to a value. It's going to look in its memory. It sees quantity right here, and it's going to evaluate as this value 4. So that quantity right there becomes a 4. So that's going to go right here. The cursor is going to stay there because that is a print. So the cursor is going to stay right there. Next, we have another print, and it is the string literal open quote space lowercase x space close quote. It doesn't need to evaluate that. That's already evaluated as a value as the string literal. So we're going to have a blank space, which I will just show as an underscore, and then a lowercase x, and then another blank space. And since that's a print, the cursor is going to stay right there. Then we have a println for price. That needs to be evaluated to a single value. It's going to look through memory. It's going to find price right here. It's going to evaluate it to 0.89. So right there, that's going to evaluate to a 0.89. That's going to get sent to the console from println. And so that goes right here, 0.89. Since that's a println, that's going to move the cursor down to the beginning of the third line. We have a print method in which we are passing in the string literal delicious question mark space. That's already a value that doesn't need to be evaluated. That can go right to the console. So right at the beginning of that line, delicious, question mark, blank space. And then finally, we're doing a print ln in which we are outputting is delicious. That needs to be evaluated to a single value before we send it to the screen. Java looks in memory, finds it right there, evaluates it to that value of true. So that evaluates to true, and then it gets sent to the screen. And so then that's right there, true. And that is a print ln. So then the cursor will be waiting for us on the beginning of the fourth line. Make sure you look that code over and you're comfortable with all of it before moving on to the next topic. The next topic is data types. You will see our learning objective, identify the most appropriate data type category for a particular specification. So you might be having a conversation with somebody and you might say, words are the best. And if it's a computer, the computer is going to say false. Numbers are number one. And you might try to prove it to them. You might try to use some words. So you'll tell them, I want to enter with a procession of horns. And so you think about yourself entering a room with a bunch of horns playing a tune to introduce you. Now, somebody hearing this might have a different idea of what that means because words are open to interpretation. Now, when somebody tells you that they are thinking of the number 6, you know what they are thinking of. There's really not a lot of confusion when it comes to numbers. So when we're working with data in our programs, data is going to be broken down into either primitive data or reference data. We're going to break those down even more. Our primitive data will be numbers and Boolean logic, and our reference data will be objects. Breaking that down even further, the numbers that we are going to be dealing with, we're going to be dealing with integers and decimals. Our Boolean logic is going to be true, false values. Our objects are going to be words. Those are going to be those strings that we've been working with. This ties into our essential knowledge. Data types can be categorized as either primitive or reference. And the primitive data types used in this course define the set of operations for numbers and Boolean values. So here you see a table breaking down our data types. Java has very specific names for these types of data. So in the green, we have our primitive data types. These are going to be the basic building blocks for programs. These are the data types that are included in your programming language by default. So we have our int data type. That's going to be our positive and negative whole numbers. We can see some examples of literals for those. Literals are just fixed value representations of a data type. So some fixed values for ints 6, -12, 0, 3462. Now you'll notice that Java doesn't use commas as thousands separators in a number because Java uses commas to separate numbers. So if you put a comma in 3462, it would think it was two numbers. It would think it's the number 3 and 462. So it uses underscores. You don't need to put comma separators. It's fine without them. But if you want to put those in there to help you, you need to use underscores and not commas. Another primitive type is double. These are going to be our positive and negative decimal numbers. So we have -15.2 is an example of a literal. We have 15 lowercase d. If we put a lowercase d at the end of a number, Java knows we want that to be a double and not an int. We could also put a capital D at the end of the number. So we could say 15 capital D. Java will know to use that as a decimal number and not as a whole number. And we can use scientific notation to write our decimal numbers as well. So we have 1.234 E4. That's the same thing as saying 1.234 times 10 to the positive fourth, which would be 12,000. And then our final primitive data type is Boolean, all lowercase. Those are just our true false values. We only have two literals for that. We have true and we have false. Now, string is not a primitive data type. It is going to be a reference data type. It's going to hold a reference to an object. Remember those string literals, those are objects. So we have some examples of some string literals. We have hello world in quotes, and we have 1, 2, 3 in quotes. Those are considered string literals. So our essential knowledge, the three primitive data types used in this course are int, double, and boolean, and a type is a set of values, a domain, and a set of operations on them. Our next topic is variables. We want to be able to declare variables of the correct types to represent primitive data. So we have a mystery box. What's in the mystery box? Take a second and try to guess. So what is it? It is something that resembles but is hopefully legally distinct from the Pokemon Squirtle. Did you guess that? All right, let's try again. Now what's inside this mystery box? Did you guess something that resembles but is hopefully legally distinct from the Pokemon Wailmer? Maybe not, but hopefully this time you guessed something closer. Maybe you were guessing a Pokemon this time. And there was something about that last mystery box that gave you a hint as to what to guess. Okay, last chance. What's in this mystery box? Did you guess something that resembles but is hopefully legally distinct from the Pokemon Chandelure? I hope so. So, what you should have seen is you should always pick the correct size for your container, and you should label that container as well. That sound means that we are going to learn a new statement. This time we are learning our variable declaration and assignment statement. This is used to create a variable in memory and populate it with a starting value. So we can see in our general form, you're going to start off with that data type first. Java needs to know what type of data you're going to give it. Then you're going to give that variable a name. A name is called an identifier in Java. And then you're going to set that variable equal to a value. So you're going to have some kind of expression that's going to evaluate to a value. In our examples box, we are declaring an int, we're giving it the name quantity, and we are initializing it with the value of 4. And you can see the other examples in there as well. So the identifier, that's just the name that you want to call that data, the name that you want to call your variable. A variable is just a named value in a program that can contain a specific type of data. So our next essential knowledge, the memory associated with the variable of a primitive type holds an actual primitive value. We saw this on our notional machine. If we look in computer memory and we look where that value is stored for our primitive data types, when they actually hold an actual primitive value. Now, these data types, they actually take up a different amount of space in memory. On our notional machine, each spot in memory takes up the same amount of space, but that's not true in the actual computer. Different variables of different data types take up different sizes in memory. So the one that takes up the least amount of space is a Boolean. You don't really need to know the memory sizes that they actually take up, but the Boolean takes up 1 byte of memory. And it can only have 2 different values, a true, false. It doesn't need a lot of space to hold these 2 different values, true and false. By default, it's the value of false, and some literals are true and false. In fact, those are the only 2 literals that it can be. The int data type takes 4 bytes of memory, and its range of values, it can be from negative 2,147,483,648 all the way up to 2,147,483,647. So when we make an int, we can make an int anywhere within that range. The default value that it picks is 0, and we have our literals positive 6, negative 12, 3,462. The data type double takes up the biggest amount of memory. It takes up 8 bits in memory, and it can store decimals with 15 decimal places. The default value is 0.0D, and our literal is 15.2, 32D, 1.234 times 10 to the fourth. So to visualize it, when we declare and initialize a variable of type int and give it the name quantity, what Java does, it goes to its stack memory and it finds 4 bytes of available data and it puts the label of quantity on it. Now, if we declare and initialize a variable of type double and give it the name price, it's going to go to that stack memory and it's going to find a space twice as big because a double takes up 8 bytes and it's going to put the variable label price on it. And then it moves these actual values into those memory locations. So why do we label our data when we program? Why do we give it a name? We've been labeling data our whole lives. Whenever we get a new item, we associate it with a name so that we remember it. We might name a baseball bat. We might name a sled. We might name a car. We label data all the time. And we do the same thing with our variables. Now, when we label our variables, when we give them a name or an identifier, there are some rules for those identifiers. There are some musts that we need to follow, and there are some shoulds that we should follow. The musts is that variables are case sensitive. So if you name a variable with a lowercase x, it's a different variable than a variable with a name of a capital X. Variable names are unlimited in length. You could have a variable name as long as you want, as long as it begins with a letter, the $sign, or the underscore character. That's it. It can't start with a number and it can't start with any other symbol. Subsequent characters may be letters, digits, $signs, or underscore characters. So after that first character, you can put numbers in there. You could put other symbols in there. You just can't start with a number or a symbol that's not the $sign or an underscore. When you are picking your variable names, you should favor clarity over brevity. So when you're naming a variable, you shouldn't just name it X just to be brief. You should make sure that you pick a name that describes that data. So you should pick a name like number of items or total after tax. Your variables should begin with a lowercase letter. Capital letters are reserved for classes. And all subsequent words should begin with a capital letter. So you'll see some valid variables in the box below. You'll see some invalid variable identifiers also in that box below. So you see our valid variable identifiers on the left, X, that's valid even though it doesn't really pass the should. It's very brief. Grade is fine. X2 is fine. $sign cash, underscore num items. Those are all valid identifiers. Invalid, you can't just name something two. You can't have the at symbol in a name. You can't call it 2x because it starts with a number. You can't call it hashtag cash because this is not one of our starting symbols. And you can't put it inside parentheses because an opening parenthesis is not one of the beginning acceptable characters. When we are declaring our variables, we can also use the Java keyword final. This is one of our other essential knowledge. When a variable is declared final, its value cannot be changed once it is initialized. So the final keyword, a keyword used for creating a constant, a value that cannot be changed. That's going to bring us to the end of our lesson. You should review how you feel about the learning objectives, read over those recap statements, hit me up with any questions or concerns that you have regarding this topic. Join us in our next video and keep programming.